All right, guys, today we're going to be solving systems of equations using the elimination method. So at the top of your paper, what I want you to write down is the elimination method. The elimination method. You can see that right here. The elimination method. You need to write that down in your binder paper, in your notes, kind of big as the big header, because that's what we're doing today, the elimination method. Okay, we just spent all of last week working on graphing. Okay, graphing to solve systems of equations. This week we are going to be focusing on the elimination method. Okay, so let's go ahead and look at what to eliminate. Okay. Elimination means to get rid of, to make disappear, okay? And so when we are elimination, what should be going through our minds is, I need to get rid of something. I need to make something disappear. And you should be writing this down. Or if you want to take a screenshot to refer to it later, you can do that, okay? Eliminate means to get rid of, to make disappear. So, the elimination method requires the alignment of like terms in columns so that one like term zeroes out and disappears. That will make a little bit more sense once we see it, okay? But I want you to write down the definition of the elimination method. The elimination method, you should be writing this down in your notes, requires alignment. Alignment means like when your tires are in alignment, it means that they're going straight, all in a row or in columns, okay? Like terms. Like terms are either your x's, your y's, or your constants. You have variables and constants, okay? And we're going to align them in columns so that one of them zeroes out and disappears, okay? You should have that written down by now. So, let's get set up for the elimination method. Now, you don't need to write both of these down, okay? I would like you to go ahead and write this half down. Go ahead and write this half down. You don't need this one, but what I'm trying to give you a picture of is when you get a problem, that's black and white. 3x plus 2y equals 7, and 4x minus 2y equals 21. I want you to write the problem down, please. But what we are doing is we are looking for the alignment of like terms in columns. Now, I color-coded this to help you see how we are aligning that with our eyes, okay? Because many of you need to begin to see how these terms, whether they are variables or constants, but you need to see how you can use them to work together. So please write down 3x plus 2y equals 7. And make sure when you write the second one, it's lined up like I have it lined up on the screen. 4x minus 2y equals 21. Okay? And we're going to take this problem, and before we get started, we need to make sure that those are in alignment. Notice that my x's are together, my y's are together, my equal signs are together, and my constants are together. So now that they are lined up, I am going to go ahead and combine like terms in columns by adding or subtracting. So what you need to do is draw this line underneath, okay, to show that we are going to add or subtract. And we're going to go down vertically. And I ask myself, what is 3x plus 4x? It's 7x. So you write that underneath. And then I look at my y's in a column. I see I have positive 2y, minus 2y. I know that 2 minus 2 is 0. And so that gives me 0 y's. Now, I'm just writing this down so that we are used to how this works. Okay? 7x plus 0y equals, notice we're still working in columns, is going to equal 28. Okay? Now that I have this, I can go ahead and simplify my equation because I don't really want to keep that 0y there. I want to go ahead and rewrite my equation more clearly. So underneath, you need to write 7x equals 28. Now on the side, I want you to write this note. These are the directions so that later, if you get stuck, you know what to do. Once one variable has been made into a zero pair. What do you mean by that, Mr. McCoy? Well, look, right here. See this 0? It made it disappear. That is the elimination. When you do 2y minus 2y is 0y, that is elimination. So when I write made into a zero pair, that's the 0y that I'm referring to. And we can now solve for the existing variable. Please go ahead and write this step down, this side note. Once the variable has been made into a zero pair, we can now solve for the existing variable. We made the y disappear, so now I can solve for my x. And I'm going to use solving equations like I've been solving equations for months now. I know that I need to use opposite operations to isolate the variable. So I'm going to say, well, 7 times x. What's the opposite of 7 times? Well, that's going to be divide by 7. Now, what I do to one side, I need to do to the other side. And so I'm going to take this and I'm going to say, okay, 7 divided by 7 is 1. 28 divided by 7 is 4. My first variable is x equal to 4. Now, I'm not done. Even though some of you are going to say, Mr. McCoy, I found one of the variables. Yes, that is good. That is necessary, but we are not done. Because in a system, there is more than one. Okay? We eliminated the y so that we can find the x. Now that we have the x, I need to use it. Okay, so everybody should have this written down by now. If you don't, you can come back to it on YouTube, or you could take a screenshot right now. 5, 4, 3, 2, 1. So here's my final step. And yes, I want you to write what you see right now. Up above, you just wrote x equals 4. And right now, I want you to write final step. Using the first variable's value to evaluate and find the second variable's value. If I were to translate that, it would say we found x, so we're going to find y. Okay, but I want you to write that down. This is called academic vocabulary. This is vocabulary that we use in school. A variable is an 8th grade thing that you need to know. A variable's value, x equals 4. The value of x is 4. and we're going to evaluate means to find the value, of the second variable's value, which is the y. So I want you to notice that we have two equations. You don't need to write both of them down again, but we need to choose the easier equation. Now, when I say easier, I mean less negatives. So when I look at these two equations, I say, you know what? I think that top one has less negatives. So I'm going to use the top one. Let's write that top one down. Go ahead, write it in your paper right now. 3x plus 2y equals 7. 3x plus 2y equals 7. And what we're going to do is we are going to find y by using the value of x. So if I'm going to use this one, and I'm going to evaluate when x equals 4. Go ahead and write that. Underneath the equation, write evaluate when x equals 4. So I want you to notice that instead of writing the variable x, I wrote the value of 4. 3 times 4 plus 2y equals 7. And what we're going to do is we are going to evaluate this equation. Let me pause for about 10 seconds to make sure that you have 3 parentheses, 4, close the parentheses, plus 2y equals 7. Okay? And we're going to go ahead and solve the rest of this equation. So I know that 3 times 4 is 12. So 12 plus 2y equals 7 is my equation. You should be writing this down right now. 12 plus 2y equals 7. Now, this is a normal two-step equation that I can solve, that you should have been able to solve in the 7th grade. And so what we're going to do is we're going to go through and we are going to solve the remainder of this equation for the variable y. So I say, well, I need to use opposite operations to get the variable isolated. I'm going to start with this 12, this extra 12 that I have on the left here. And I have to ask myself, what's the opposite of add? Or what's the opposite of positive? And the answer would be negative. What I do to one side, I do to the other side. So I want you to notice that I say 12 minus 12 is going to be 0. 7 take away 12 is going to be negative 5. Okay? The 2y comes down. And notice that I am simply solving these equations. So my next step, I have 2y equals negative 5. And you think, oh man, I don't know. That's hard. Well, we always go back to opposite operations. The opposite of multiply is divide. And so I just follow the steps. I divide the left side by 2. I divide the right side by 2. Okay? 2 divided by 2 is 1. I've isolated the variables. Negative 5 divided by 2 is negative 2.5. You could do 2.5. You could do 2.5. Some of us even leave it as an improper fraction. Okay? Now, some of you, when you get a decimal, you think you get it wrong because it didn't come out evenly. Guys, we have decimals all over the place. In fact, we have more decimals than we do whole numbers. So it is completely acceptable to get an answer that is a negative, that is a decimal. It is not a big deal. Okay? Now, I have gone through and I have evaluated this equation when x equals 4 so that I can find the value of y to be negative 2.5. However, I need to write my answer in a very specific way. When you know x is 4 and y is negative 2.5, you need to write your answer as an ordered pair. Make sure you write that down in your notes. Write your answer as an ordered pair. If x is 4, it comes first in the ordered pair. If y is negative 2.5, it goes second in the ordered pair. It's always x, then y, alphabetically, okay, in ordered pairs. Now, we have systematically gone through this problem, okay? We have eliminated one variable so that we can find the second variable. We use the variable that we know to find the other. You have to tackle the problem one piece at a time. Okay, there's a famous saying that says, how do you eat an elephant? Something that is so large and it seems impossible to do. But you do that one bite at a time. You do one piece at a time. You don't try and tackle the entire thing. You just tackle it one piece at a time. So there is solving systems of equations by using the elimination method.